Alright guys, welcome back. This is actually the last video for this week on the unit circle. And the goal by the end of today is that you're able to really quickly fill out radians all around the unit circle like I showed you in the last video, and also degrees, and figure out with the radians we filled out, ones like pi over 4, pi over 3, what are the degree values that would match up at that exact same line? That's really like the main thing of today. So let's do a quick kind of recap on what we talked about in the last video, which is filling out radians. And I'm going to show you how I do it really quickly, and how this is how I write down the unit circle every time. So I know that the ones that are over 6, and I spoke about this in the last video, they're these ones here, the ones that end up being a fraction over 6. And I think about that because they are the ones that are closest to the x-axis. And also, if you draw a rectangle, see how they're all symmetrical? And so I always start with that. So this one, let me go back and highlight them again. This one would be my first one, so 1 over 6 pi. But again, remember that we do normally write that as just pi over 6. Okay, and if we were to have divided the entire top half of the unit circle in 6 pieces, there would be a lot more than just these 2 highlighted. And I'm saying 2 because I'm just looking at the top half right now. So the other one, the next one would be right here. That'd be 2 pi over 6, 3 pi over 6, 4 pi over 6. Then this one would be 5 pi over 6. Okay, so I don't actually go through and write them all over 6 and then reduce my fractions. Once you get in the habit of knowing where these are, this is just kind of a quicker way of doing it. Okay, and then I know that this right here would be 6 pi over 6, and I know that because that spot is just pi. In fact, I can fill that in right now, which means my next one would be here at 7 pi over 6. My next one would be here at 8 pi over 6, 9 pi over 6, 10 pi over 6, which means this one would be 11 pi over 6. Okay, and now I have all the ones filled out that end up having a denominator of 6. So now let's do the same thing, but with the ones over 4. And the ones over 4 are always these ones in the middle, right here. And again, if you were to draw a rectangle, these would all be symmetrical. And so that's what helps me just kind of keep it straight, not get like any of them mixed up, is visualizing those rectangles drawn in. Okay, so let's fill out the ones that would be over 4. So the first one would be 1/4, or just pi over 4. This one would be 2/4, and then this one would be 3/4, so 3 pi over 4. And then of course this is 4/4, so down here this would be 5/4. This one here would be 6/4. This one here would be 7/4. And the reason I'm skipping some is because the ones I'm skipping are the ones that end up having a fraction that reduces, and I'm going to get those later. Okay, and then last is let's do the ones over 3. The ones over 3 are here, 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 and here. And these are the ones that are closest to the y-axis. And again, if you were to draw a rectangle, all the ones that end with the yellow spoke that I highlighted, if you draw a rectangle, these would all be symmetrical. Okay, so my first one would be pi over 3, 1/3. My second one would be 2/3, or 2 pi over 3. This would be 3/3, so this one down here would be 4/3, and then 5/3. Okay, and then I pretty much have everything except for the halves, which would be the ones that I outline in black. So this one up here is my first half, so that's just 1/2 pi, or pi over 2. And then this is 2 halves, so you write that like that, which we know is just pi. This one down here is 3 halves, so 3 over 2 pi. And this one here is 4 halves, or 4 over 2 pi, which is just 2 pi. And we could have filled that one out a long time ago. I just didn't. Okay, so this is the entire unit circle filled out with all the radians. That, what I just went over, is how I actually do it so that I can go quicker. And I don't have to like sit there reducing fractions and make it like really complicated and sloppy looking. So this is something that you need to be able to generate in like 1 to 2 minutes on your own. If I were to give you the blank screen again, you need to be able to fill that out pretty quickly, because I'm going to be asking you for things like show me the angle where 5 pi over 6 is. And I need you to be able to like come up with that pretty quickly. So that's going to be part of today's work, is filling out, again, the unit circle with radians. But in addition to that, I also want you to know what are the degree values. Like, for instance, at this particular spot, pi over 6, like, how many degrees is that right there? We filled it out in radians. Can we also fill it out in degrees? And can we show both at the same time? So let's explore that. Okay, so looking at part A, if I just look at the top half of the unit circle, and the reason why I always tell you guys look at the top half is because this right here is it's like one whole, it's 1 pi. So one whole thing is just half of the circle. That's why we always look at it in halves. Okay, so how many pieces did they break it up into? They broke it up into 4s. And so we know that would be 1/4 pi, 2/4 pi, 3/4 pi, 4/4 pi. And that actually tells us exactly what those degree values are. So we know this is pi over 4. This is 2 pi over 4, which, let's think about that fraction. That would reduce to 1/2, so pi over 2. And this is 3/4 pi. So we just figured out, just kind of by looking at how many pieces they divided up the unit circle into, what the equivalent of 45 degrees is in radians, and what the equivalent of 90 degrees is in radians, and 135 degrees, and we can keep this up. In fact, let's do that. So we left off at 4 over 4, so this would be 5 over 4 pi. This would be 6 over 4 pi, which reduces to 3 over 2. This would be 7 over 4 pi, and 8 over 4 pi, which reduces to 2 pi. So we just found out all the equivalent degree values. Another way that we could have known that that would be true is if you think about pi being over here, and we know pi is 180 degrees, if I take 180 degrees and I want to divide it by 4, I would get 45. Just on your calculator, 180 divided by 4, you get 45, which shows you that if you were to cut it into 4 equal pieces, that you know you have to go up by 45 degrees every time in order to be able to make it all the way around 180. So that's another way of thinking about it. Okay, let's do the other one, and let's see what they divided up. So if I look at the top half, it looks like it's divided into 6 equal pieces, which shows me that this would be pi over 6. And now I know what 30 degrees is in radians. It's pi over 6. And I can continue this. The next one would be 2 pi over 6, which reduces to 1/3. The next one would be 3 pi over 6, which reduces to 1/2. And then 4 pi over 6, which reduces to 2/3. And then 5 pi over 6. And so now I know what all these equivalent degree values are in radians. Again, kind of another way of looking at it is if they divided it up into 6, and we know that over here is 180, then just divide 180 by 6 and see what you get. And you would see that you get 30. So then you know that each one of these spokes is separated by 30 degrees, and if you go around 6 times, you get all the way back to 180. Okay, so I want to kind of show how this connects to when we were converting back and forth between radians and degrees. I just showed on the unit circle kind of visually why this is true, that pi over 3 is 60 degrees. We did that one. This was the one right here. And so let's show why that works with algebra. So if I started with pi over 3, and this is radians, and I want to convert that to degrees, then I would multiply by the fraction 180 over pi. That way my units here will cancel with radians, and I'll be left with an answer in degree. Also, what cancels is the pi. So really the only math I have to do is 180 divided by 3, and when you do that, you get 60. So we verified, even just using my little formulas that I learned yesterday, that pi over 3 is 60. Okay, let's do the next one. How about pi over 6? If I want to convert that to degrees, I would multiply by 180 over pi, and several things cancel. The radians cancel, the pi's cancel, so all I have to do is 180 divided by 6, which will give me 30 degrees. Okay? And let's do the last one, but this time, how about we go backwards? Let's start with 45 degrees. So if I start with 45 degrees, I'll even write in degree. I'm going to times that by 180 in the bottom. That way the units of degrees will cancel. And then pi radian in the numerator. And remember, I'm always leaving my radians with pi in the answer. So I'm not actually going to multiply by pi. I'm just going to reduce this fraction, 45 over 180. If you type that on your calculator and reduce the fraction, you'll see that that's 1/4. So then I know this is 1/4 pi, which is the same thing as just pi over 4. So we verified using algebra that this works as well. Okay, so now we should be at the point where you can fill out both radians and degrees. So just like we started in the warm-up, this slide over here, where I just did radians, we should be able to go through and say, okay, this is pi over 6, this is pi over 4, this is pi over 3. But I should also be able to fill out the degree values. I should be able to say, well, this is the same thing as 30 degrees, this is the same thing as 45 degrees, this is the same thing as 60 degrees, and my next one would be pi over 2, and I know this is 90 degrees. So you should be able to go through and fill all of that out. I'm going to show you a easy way of like looking at patterns, and then I'm going to have you guys pause it, and I want you, the ones that you're printing out at home, the blank ones that look like this, once I show you the shortcut, I want you to do that 3 times with both radians and degrees before moving on. So a quick easy way that I always remembered is that these like spokes, as I keep calling them, are all separated by 15 degrees. So 30, 45, 60, you just go 15 degrees up each time. But then to the bigger sections, like to the x and y axis, there's a difference of 30 degrees. So there's 30 degrees here and 30 degrees here, but then there's 15 degrees just in between each one. And that's the same thing all the way around. So if we do that again, there's 30 degrees here, and then it's 15, 15, and then back to 30. And then same thing all around, 30, 15, 15, 30, 30, 15, 15, 30. So you can start by just going, okay, 30 up, that's on 30. Now go 15 up each time, so that's how I get the 45, and then 15 up again is 60, and then go 30 up, gets you 90. 30 up again gets you 120, and then 15, 15. So if you go through it that way, it's pretty easy to fly through it pretty quickly. Okay, so at this point, it's really, really important. This isn't really just like a suggestion. Like, honestly, learning the unit circle and being able to do it quickly is going to be really helpful for you. So at this point, I want you to go back to Google Classroom, print out the page that looks like this, and I want you to be filling out both radians and degrees 3 times to make sure you really got the flow of it. And then when you're done, you can check your answers. So I'm going to leave the screen here and have you guys pause it, do that, and come back and play the video when you're ready to move on. Okay, so we should be pretty good at knowing where angles and radians are on the unit circle. So now when I ask you questions like this, we should be able to answer them pretty quickly without having to actually draw the entire unit circle out. So the first one says 225 degrees. So what I'm going to just already jump to is I know that right here is 180. So I don't need to fill out any of the stuff before it because it's obviously not going to be any of those. So right here's 180. If I go 30 more, I would be at 210, so this one would be 210. I still need to go more. If I go up 15 more, which would be the next spoke, that would get me at exactly 225. So I know this blue one here is exactly where that angle would be, but of course that's always starting from 0. So this is the initial side, and this is the terminal side. And I need to show my arrow going this way. We went positive, so it's going counterclockwise. Okay? Next one is 13 pi over 6. So we want to think about just the ones that end up being over 6, which are these ones right here, the ones that are closest to the x-axis. And 13 pi over 6, that's a pretty large improper fraction. Like, what is 13 over 6? Well, I know that 12 over 6 just reduces to 2. So that means 12 pi over 6 is 2 pi, which is right here. So I know I need to just go one extra 1/6 above that, and which would end up being right here. So I can erase these other ones, and I know that my answer is going to end up being at this spoke right here. It's like going all the way around and then going an extra 6. So when I draw my arrow, I just need to show that. I didn't just go straight up to that. I actually went all the way around the circle and then an additional little part. So I need to draw the extra loop in there, and that is 13 pi over 6. Okay, let's look at the next one, which is negative 540 degrees. Okay, so negative means I'm going clockwise. I'm going to start by going down. But if I go all the way around the circle, I'm going to be at negative 360 degrees. So let's just pretend I did that, and I'm right back to where I started, and I'm at negative 360 degrees. So now let's see how much further I have to go. Well, 540 minus 360, the difference between those is 180. So I know if I went all the way around once and I just ended up right back here, I need to go an extra 180 degrees, which would end up being here. So my angle ends up looking like this, like a weird, well, just a flat line really. But I do need to show that in my arrow that I went all the way around and then I did this extra half. And that's how I'll graph negative 540 degrees. Okay, last one is negative 7 pi over 3. I know the ones over 3 are going to be one of these four. So my answer is going to be one of these four. And it was negative, so I know that I started off by going clockwise, by going down. And so let's count that. I could just go, okay, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, and figure out where that is, being right here. Another way you could think about it is negative 6 over 3. Well, that just reduces to negative 2, and if that was a pi, then this would be negative 2 pi, which is right here. But I need to go not negative 6 over 3, but negative 7 over 3, which means I need to go one more extra. So either way you want to think about it, you end up being right here. So let's clean that up a little bit now that we know where that is. I'm going to be starting at 0, and I ended up here, but I had to go all the way around one time before I got there. So I need to show that loop when I draw in that angle. Okay, and if you understand these, if you understand how to do it in both degrees and in radians like this, and be able to graph these angles in what we're calling the standard position, then you guys are all good to go. And at this point, we're going to be moving on to the last thing, and then that's it for your videos for this week. Okay, so the last thing that we need to go over is how do you calculate the length of an arc, like something like this? Like, what's the length of that? And it's not, like, I can't just, like, get a ruler out, obviously, because it's curved. So I need to figure out some formula for that. So that's one thing we're going to figure out. You did learn a formula for that in geometry, but the formula we're going to learn is a little bit different because we're going to talk about the angle in radians. So it changes our formula a little bit because embedded into the formulas that I give you is already converting from degrees to radians. So you don't have to do this like extra conversion. These formulas already take into consideration that theta, your angle, is in radians. So if it's not, if it's in degrees, then you're going to have to do something different. Okay, so, and when I say something different, it's not harder. It's just, if it is in degrees, then you go back to the formulas that you would have learned in geometry. Okay, so we're going to learn arc length, and then we also want to learn sector area, which is the area of not the entire circle, but just like a certain shaded region. Okay, and these are your formulas right here. So I would maybe write these down on your paper before we move on. That way you just have them to look at, and you don't have to, like, rewind or anything to find them. Okay, so the first example is I want to find the length of the fence and the area of the field. So I'm going to be doing both sector area and arc length. So again, using these formulas, let's write them down at the top of our paper. And why don't we start by just doing the length using this first formula here. Remember, this formula is including that your angle is already in radians. But this right here is not in radians, that's in degrees. So what is 90 degrees into radians? Well, you could either do your conversion formula, or you could think about this on the unit circle, that 90 degrees is right here, and that's the same thing as taking the upper half and cutting it in half. So that would be pi over 2. So, however you want to think about it, we just need to know that 90 degrees is the same thing as pi over 2, and that's what I want to be plugging into my formula. All right, so let's do the length. So we're going to do r is the radius, and the radius is 200 feet. So I'm going to do 200 times pi over 2. And typing that on my calculator, you should get 314.159, blah, 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 and it keeps going on. We're just going to round this to the nearest whole number. And so I'll write that as, I'll just say about 314 feet. and I found the length. So it's really, really easy. Once you have these formulas, it's super easy. The only thing you have to remember is always convert to radians because these formulas are not meant for degrees. The ones that you learned last year in geometry are the ones you would do for degrees. Okay, so now let's do the area. Let's find the area of that whole green part. So the area is 1/2 times the radius squared, so I gotta make sure I square that, times theta in degrees, which would be pi over 2. Okay, so type that on your calculator and see what you get, because I just need to make sure, well, you need to make sure that you're typing it in correctly, following orders of operation. But what you should be getting is 31415.926, blah, 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 and then it keeps going on. If we're rounding that to the nearest whole number, then that would be 31416. And this is in, so 31,416, and this is in feet. But remember, it's area, so feet squared would be my answer for that. Okay, so that's it for sector area and arc length. They're really straightforward, especially once you have those formulas and once your angle is already in degrees, it's really easy. Okay, so let's do the one last thing for today, which is just to kind of recap and review, and this is your last video for this week. The rest of the 2 days, so Thursday and Friday, are to work on your weekly assignment and make sure that you're practicing filling out the circle, the unit circle every day. So this problem wants us to convert 300 degrees to radians, and then it has other things. So let me first just do that. So 300 degrees, let's convert that to radians. So if I want it to be in radians, then I need to make sure that I put degrees on the bottom. That way those units will end up canceling. So I'm going to multiply it by this fraction and figure out what that is on my calculator. But if I want it in radians, I want to keep pi in my answer. So I just need to reduce this part of the fraction, 300 divided by 180, get that as a reduced fraction. And you should get 5/3. So when I convert that to radians, I'm getting 5/3 pi, or you could say 5 pi over 3 radians. So I'm done with that part. I've converted it to radians, and now I want to name two angles that are coterminal with 300. So what that means is that when you draw them, they look the exact same, but maybe you've just gone around an extra time around the circle. Well, since I already have an answer in radians, why don't we just keep working with radians and answer our coterminal angle in radians. So I know going around the circle is 2 pi. So I'm going to take my answer that I just got for 300 degrees, and I'm just going to add 2 pi to that. Okay, now note that that's not going to be 7 pi over 3, right? Because adding fractions, you have to have common denominators, and 2 pi has a denominator of 1. So I need to think about how to add those in a better way. So let's write that down. 5 pi over 3, and I want to add 2 pi to it. Well, I need it to have a denominator of 3, so I need to multiply the top by 3 to counterbalance that. So multiply 2 by 3, and you get 6. So 6 pi over 3 is the same thing as 2 pi, but just with common denominators. And when you add that together, you get 11 pi over 3. So that tells me that 5 pi over 3 and 11 pi over 3 are in the exact same spot on the unit circle. That's why they're called coterminal. Okay, so now let's do the same thing, but why don't we subtract 2 pi from the original one and see what we can get. Hopefully we'll get a negative. If not, we'll have to just subtract it again. Since I already did my common denominators over here, I'm just going to turn that into a subtraction sign and see what I get. So 5 pi over 3 minus 6 pi over 3, I'm going to jump that over here. 5 minus 6 is -1, so it'd be negative pi over 3. So I only had to subtract 2 pi once, and I was already into a negative angle, and so we're good to go. So all three of these ones boxed in. 5 pi over 3, that's the equivalent of 300 degrees in radians. And this one right here, and this one right here, on the unit circle would be in the exact same position, and that's why they're called coterminal. I got one positive and one negative, so I'm good to go. Alright guys, so that's it for the lessons this week. Make sure you are printing and filling out your unit circle both in radians and degrees at the same time. And just take the next couple of days to practice that and get that down and work on your assignment. Have a good week. Bye guys.